Now that we understand the mechanism behind CloudGuard serverless security, let's roll up our sleeves and start deploying. In our use case, since we're deploying to AWS, we'll be talking about an AWS-oriented deployment. The overall process consists of the following steps: onboarding a designated AWS environment into CloudGuard native, enabling serverless security, enabling runtime protection, and creating exclusions and rules. First, we need to onboard an AWS environment into CloudGuard native. CloudGuard native has two operation modes for managing AWS accounts, either read-only or full protection. Read-only allows you to monitor and examine AWS accounts within CloudGuard. Full protection, on the other hand, has a more proactive level of enforcing access and tamper protection on your AWS assets, managing security groups, and controlling direct access to your cloud assets. There are a few methods to perform onboarding, from a step-by-step process using CloudGuard and the AWS console, to automating the process using batch scripts, Terraforms, and REST API calls. In our case, we'll focus on onboarding from the CloudGuard portal. To begin, we navigate to Environments and add a new AWS environment. Now we need to select an operation mode. In our case, we'll use Full Protection. The next steps involve following the CloudGuard Wizard, which instructs you how to prepare an IAM policy in the designated AWS account, granting appropriate permissions to CloudGuard to access the AWS account for information about resources. Additionally, it details how to create an IAM role in the AWS account to be used by CloudGuard to access the cloud account using the IAM permissions defined in the previous step. Let's assume we've performed these easy and straightforward steps listed in the wizard, and we've arrived to this summary screen. Based on the number of entities in the AWS environment, the process may take a few minutes to complete. This completes the onboarding process. Once fully onboarded, you can view your AWS environment and its status. Now that things are onboarded, let's enable serverless protection. To enable, we navigate to Environments and choose Enable Serverless Protection. Now we create a cross-account role. After acknowledging, we create a stack. After the stack is created, the additional permissions are granted to CloudGuard, and CloudGuard completes the process of enabling protection. When this is complete, as indicated in the CloudGuard Wizard, you can see the serverless functions in the protected asset list for the account in the Protected Assets page. You can now examine the static code results and the posture findings generated from the scan. Now it's time to enable the runtime function self-protection to allow the comprehensive protection that is expected from CloudGuard. To enable, we navigate to the Serverless Functions page. We select the desired function from the list. Now we switch Auto Protect on. The profiling will commence and will complete the allow list. Since we'd like to block malicious actions that are not in the allow list, we toggle on Block on Detect once Auto Protect is done applying itself. Finally, let's define an exclusion which will manually add access in the allow list to an allowed asset, in this case, text files under the logs directory. First, we select our target function and navigate to its Rules and Exclusions tab. Then we create a new exclusion and select its target, in our case, a file. Now we enter the exclusions pattern, which is a string or a set of strings that matches against actions. If an action matches a pattern, it is added to the allow list and excluded from further inspection. In our case, since we're matching text files under the temp logs directory, we use this pattern. Finally, we select the scope this exclusion applies to, a specific function, a group of functions, or the entire set of functions in the environment. And there you have it. We've gone through how CloudGuard can protect your serverless functions, constantly analyzing and profiling the behavior of the function components, providing built-in function self-protection. And we've examined an implementation of CloudGuard Serverless Security in AWS. If you'd like to enhance your knowledge on implementing this solution on other platforms, such as Azure, please refer to the product documentation. Thank you for taking this session. I hope you found it useful, and I'll see you in the next one.